Geomatics engineering, math count. First question. In Rockstone City, no building is permitted to be taller than the monument to the city's first mayor, Mayor Rockstone. A new developer wants to build an apartment building in Rockstone City, but does not know how tall the monument to Mayor Rockstone is. A 35-foot telephone pole next to the monument casts a shadow that is 15 feet long. If the monument's shadow is 257 feet long, at the same time of day, how tall is the monument to Mayor Rockstone? Express your answer to the nearest number of pole feet. Let's review this question. So the builder wants to find how tall the monument is. So let's see. There is a 35-foot telephone pole next to the monument that casts a shadow that is 15 feet long. So if the monument's shadow is 257 feet long at the same time of day, how tall is the monument to Mayor Rockstone? Express your answer to the nearest whole number of feet. So nearest whole number. Well, it's kind of talking, there's different objects, so I think the best way to do this is to draw a picture. So right here, this is my telephone pole. And over here, of course, is the much bigger monument. So this is a telephone pole, and it is 35 feet. But right now I'm just going to use 35 just to, write less. So the shadow is 15 feet long. Okay, so this shadow right here, this shadow comes exactly right here. So if the monument's shadow is 257 feet long at that same time of day, just so on, 257 feet long, then how tall is a monument to Mayor Rockstone? So there's a ratio size right here. It's at the same time of day, which means it's the same ratio. First, we have the shadows, 15 to 257. So this is the shadow of the telephone pole, and this is the shadow of the monument. So we know that the telephone pole is 35 feet. So what would this spot be? Well, first let's find 1. What would it be if it was a 1? Well, then it would be on the right side, it would be 257 divided by 15. We want to get a equivalent ratio, and that's about 17. So if I multiplied a 35 up here, and I would also have to multiply 35 on the right side to 17, and that equals a good 595, which means that the height of monument to Mayor Rockstone is 595. Remember that label, so feet. The answer is 595 feet. Alright, so now we'll be starting problem 2, taking what we have so far to the next level. So let me clear the space out. Okay, let's read problem 2. LiDAR, or light detection and ranging, is a method used in geomatics engineering to determine distances and other measurements of natural formations either on land or underwater. To measure distance using LiDAR, a laser light source is shot from one point to another and bounces back. The distance, d in feet, between the 2 points is calculated by multiplying the time t in seconds it takes a laser light to travel from one point to another and back by the speed of light. C in feet per second, and then dividing the result by 2. Since the light travels at a constant speed of 983,571,056 feet per second, we can use the following formula, and this is the formula already written for you. So basically all we have right now is some variables and the equation, the formula. Now let's read the problem. What are we trying to find? The developer uses LiDAR to determine the length of the rectangular plot of land on which she plans to build the apartment building. If the time it took the laser light to travel the length of the plot and back was 4.03 times 10, and this would be 10 to the 7th power, raised to the 7th power, seconds, how long is a plot of land? Express your answer to the nearest whole number of feet. Alright, so first we have this equation, which is handy. Now let's think about so we're trying to find the nearest number of feet and how long is a plot of land. First, what is the length of the plot of land? So we know that that would be the distance, right? That's the distance in feet between the 2 points. That's D. So we're trying to find D. And so all we need is times T with this huge number right here and divide that by 2. Then that's how we will get D. So first, what is T? Well, we know that T is equal to 4.03 times 10 to the 7th power. So let me rewrite the equation. We have 4.03 times 10 to the 7th power times 983,571,056. And we divide that whole thing by 2. Okay, maybe I'm going to make it a little bit smaller. So this is what we have right now as our equation. So how can we simplify this? We're not just going to go up and do this whole thing. We're going to find a way for us to really have an order to. So over here, we already have 4.03 and 2 very huge numbers. This is an exponent, which means it's multiplying 10 together 7 times. That is awfully big, and just going to make this tremendous number even bigger. So how can we do this? Well, first there's a 2, so I'd like to get rid of the denominator. So why don't we divide the 2 with, cancel it out with this number right here. So all we do is divide it by 2, right? So the 2 cancels out, and this we get 491,785,528. And we're going to continue the calculation. So 4.03 times 0.7 times 491,785,528. And the problem says express your number to the nearest number of whole feet. So that's just going to be about 4 times 10 to the 7th power times 491. Okay. Now this is just calculation. So as it is calculation, all you have to do is have a good, strong, understanding of multiplication and multiply. So I'm first going to do 4 and this number right here. Stack them first. Okay. And times 4. Alright, let's do this with me. So 8 times 4, 32. Carry that 3. 2 times 4, 8. Plus that 1, 5 times 4, 20, plus that 1, 21. 5 times 4, 20, plus a 2, 22. 4 times 8, 32, 40. So 34. 7 times 4, 28, 31. 1 times 4, 4, 7. 9 times 4, 36. Carry that 3. 4 times 4, 16, 18. So what we have next is okay. What we have next right here is a really big number, 1,867,142,112. Times that with 7. Really, all we're doing is adding 10 more 7s in the back. So how long is a plot of land? That would be 1,867,142,112. We're not done yet. 1, 2, 3, 4, 5. I don't want to take up working space. So 1, 2, 3, 4, 5, 6, and 7. So that is our final answer for the second problem. I know a lot of numbers, a lot of big numbers, especially calculation, but it's nothing hard. So as long as you really know it's okay. Okay, now we're moving on to problem 3. The rectangular plot of land, which has a width of 110 feet, has a slope or grade of 30%. So this means that over 100 feet, the land rises 30 feet. So let me quickly show you what it means. So it's saying, right, if this is 100 feet across, right, it goes up 30%, which means that it rises 30 feet. So the land slope now looks like this. This is a slope. So it's not a flat piece of land. It's actually sloped. So which means over 100 feet, the land rises 30 feet. Now you got the idea. Assuming the land rises across the width of the plot, so it rises across the width of the plot, how many total feet does the land rise? Okay, so you get the idea of what it means. So now just all the calculation. So, well, the easiest way is to draw a picture. It's saying that it rises over the width of the plot. And we know that the width of the plot is 110 feet. Great, so we have right here, and we're going to label that 110 feet. This is the width of the plot of land. Now we're going to try to draw a picture of it rising 30%. So this is saying, in this 110 feet, for every 100 feet, it moves up 30. So over here, I'm gonna draw this is the 100 feet point, okay? So this would be 10. This is the 100 feet point. So it's saying that the slope will rise up, and at this 100 feet point, it's going to be 30 feet. It's kind of similar to the diagram I earlier just had right here. So that's a 100 mark point, but you have to know that this width is 110. So how much more will it go for the 10? So this part right here, we know it's going to be a rectangle. Sorry, a triangle. So let's zoom in on that. So let's zoom in on that. And now we have this is a base right here, right, of 10. And for every 100, so for every 100, it rises 30 feet. So let's take an equivalent fraction to have a denominator of 10. That's what it is right here. So after it's simplified, it equals 3 over 10. So it's saying for every 10 feet, it rises 3 feet, which means that over here it rises 3 feet. And we know that that's what's over here, right? We just zoomed in on that earlier. So we know that right here, this is 3 feet. It rises 3 feet. But we're trying to find what this line right here is. And I'm going to highlight that in yellow, what this line is. But we see that it's exactly this 30 feet plus this 3 feet. So 30 plus 3 equals 33 feet, which means that across the width of the plot, the total feet it rises is 33 feet, and that's our final answer. We finally made it to problem 4. Before beginning construction, the ground must be leveled in order to build on a flat surface. If the company contracted by the developer charges $125 per cubic yard for dirt removal, what will be the total change to remove on this 135,000 feet squared of dirt to level this plot of land? So what do you think we need? Well, we need a picture. We need to maybe make a diagram. We need to, we know that this is a problem with money, so there must include multiplication and division of some sort. Anything else? Okay, so I'm probably saying you haven't noticed that these two units are different. One is yard and one is feet. So in order to have a proper interaction with this company right here, we need to tell them how many yards there is, not how many feet. So first we need to convert it. So we know that there are 3 feet in 1 yard. So since the company only talks with yards, let's first divide the number of feet, which is 135,000, and divide that by 3, because there are 3 feet in 1 yard. So this is 12, 1, 5, 5, 15. Okay, that's 0. And then we just add these zeros right here. So basically, we have 405,000 cubic yards. So what would be the total charge to remove this amount of dirt? So now that we have the units done, it's time to calculate, and we're going to do that by multiplication. We have this much cubic yard, and for each of those cubic yards, there's $125. So we can write the equation 125 times this 45,000. Alright, so I'm gonna first put away these zeros and just do 105 times 45. That would be equal to 1,000, right? This 1,000 times, and over here we have 125 times 40. I'm gonna split this 45 up, plus 125 times 5. I split this 45 up into 40 and 5. Okay, so we're going to leave this 1,000 on the outside, right? On the inside, we have 125 times 40. So we know that it ends in a 0, of course. 5 times 4 is equal to 20. Carry that. In the end, you should get 5,000 plus 125 times 5. So 5 times 5 is 25, 12, and 6. So you should get 5,000 plus 625. Then, this in here, it adds up to 5,625. And times 1,000 would be 5,625,000. So the total amount of dollars used to remove this plot of land would be $5,625,000.